Welcome back to this video tutorial for digital electronic and logic design. So we have completed unit 2, and in this session we are going to start with unit 3. Unit 2 was about combination logic circuit, and unit 3 is about sequential logic circuit. The difference between combination logic circuit and sequential logic circuit is that sequential logic circuit, it uses the clock signal in order to start the circuit. In case of combination logic circuit, we do not require the clock signal. And the other difference that which we have looked into the introductory part of unit 2 is the difference between sequential and combination logic circuit. In case of sequential logic circuit, it will act as a storage device where it can store the bits. Similarly, the combination logic circuit, sequential logic circuit, in sequential logic circuit, we are going to look into different type of sequential circuit. We are going to focus on 3 types: flip-flop, first one, second counter, and finally the register. So all those examples are type of sequential circuit, and they have a capability to store the bits. So this makes the difference from combination logic circuit. Now first, we are going to look into flip-flop. In flip-flop, we are going to look into type of flip-flop, truth table, and IC version. Now, so this is the introductory part. You may read yourself. Now, in case of flip-flop, it has 2 stable states. So such type of device is known as bistable state. So similar to flip-flop, there is another circuit which is known as latch. Latch and flip-flop, which has bistable state. So therefore, both the circuit are bistable state. So when we say bistable state, so we have 2 states. So either it will be 0 volt or either it will be 5 volt. 0 volt in case of digital electronic, it is represented by logic 0, and plus 5 volt is represented by logic 1. Now, in the last sentence, flip-flop circuit can be constructed from 2 NAND gate or either using 2 NOR gate. So with the help of that universal gate, we can construct our flip-flop. So if you recall the difference between sequential and combination logic circuit, so we remember that in case of sequential logic circuit, the building blocks, the main circuit that we use to design the sequential circuit is none other than flip-flop. So therefore, this flip-flop circuit is used to construct different type of sequential circuit like counter and register. So we are going to look into register and counter after we complete studying flip-flop. Now we have different type of flip-flop: RS flip-flop, clock RS flip-flop, delay flip-flop, which is in short known as D flip-flop. We have JK flip-flop, we have toggle flip-flop or T flip-flop, and we have master select flip-flop. So these are the type of flip-flop. So we are going to look into individual flip-flop, and we are going to look into logic diagram, truth table, and explanation for each flip-flop. First, we have RS flip-flop. So this one is logic diagram of RS flip-flop, and this is the symbol of RS flip-flop. So this symbol, so we are going to use when we construct counter and when we construct the register circuit. So this symbol will be used. Basic RS flip-flop, RSFF means RS flip-flop, circuit with NOR gate. So this one is constructed using 2 NOR gate. Each flip-flop has 2 output. We have Q and Q bar. We have Q and Q bar. So each flip-flop has 2 input, set S and reset, where it is represented by R. Set is represented by S and reset is represented by R. So if you look into this symbol, so you have two output, Q and Q bar, and you have two input, which is known as set and reset. Now this is the truth table of RS flip-flop. In the truth table, if you look here, when you give your input set and reset equal to 0, 0, that means your output will be no change. So that means it will remain the last value. So if you had 0, then it will remain 0 itself. So which means no change. When you give S0 and R1, so the value will be 1, so which means it is set. Now when you interchange the input S and R, then your output will be 0, that is reset. And when you give both set and reset high, that means there is no output, which means it is forbidden. So when you write the truth table, you should careful that you need to write the action as well. So you have two input and output, and you have the action. So if your output is 1, so it means set. If your output is 0, it is reset. When the both input is high, so there will be no output, so that is forbidden. So we cannot use that type of input. And when you give 0, 0 at the input side, so there is no change. So if you look at here, NOR gate output is 0 if any input is 1. So this is talking about truth table of NOR gate. NOR gate output is 1 only when all the input are 0. True state, state 1 when Q equal to 1, and state 0 when Q equal to 0. So this is the true state. So as I said, flip-flop, it is two state. Either it is 1 or either it is 0. So therefore, if you look out here, so you will have only two output. Of course, we have option of getting 4 output because of combination from the digital bits. So if you give 0, 1, 0, 1 and 0, 0, 1, 1, so we have a possible output are 4. We may get 4 output, but as flip-flop is bistable state, it should have only 2 output. So it is either set or reset, 1 or 0. 1 means plus 5 volt, 0 means 0 volt. Now this is the explanation of this truth table. So you may go through, and if you don't understand, you can clear your doubt. Now similarly, this is the clock RS flip-flop. The difference between simple RS flip-flop and clock RS flip-flop is, in case of clock RS flip-flop, you have clock at the input side. So you are giving the clock signal. And the logic diagram for clock RS flip-flop is given out here. And this is the graphical symbol for clock RS flip-flop, where you have two input, that is R and S, and also the clock, and output Q and Q bar. The addition of two NAND gates at R and S input will result in flip-flop that can be enabled or disabled. When the enable input is low, the NAND gate output must both be low and change in neither R nor S will have any effect on flip-flop output Q. The flip-flop is said to be disabled. Now if you read out this one, when the enable input is high, so which means you are giving the clock, the information in R and S input will be transmitted directly to the output, and the flip-flop is said to be enabled. So when you enable this clock, only then your flip-flop will start working. Otherwise, your flip-flop will be disabled in this state. So this is the truth table for clock RS flip-flop. So if you look out here, so again, in case of clock RS flip-flop, you will have only 2 output, that is set or reset. Now if you look out here, so I said in order to enable your RS flip-flop, the clock signal should be high every time. So out here, fast when both input set and reset is 0, 0, so your output will be no change. So that means it will be previous output. Now when your input set is 0 and reset is 1, so it will be reset. And your clock signal should be high. This should be high. This should be high every time in order to enable your circuit. So you have two output, that is reset and set. This is the truth table. So you may compare the truth table between simple RS flip-flop and clock RS flip-flop. And this one is D flip-flop. Now all the type of flip-flop that we are going to look are almost similar. The only thing is there will be a few change in the circuit diagram. Now in case of simple RS flip-flop and clock RS flip-flop, the only difference was in case of clock RS flip-flop, the input at the input side we have given the clock in order to initiate the circuit. Now we have again D flip-flop. D flip-flop is the nothing but it's the modification of clock RS flip-flop. Now since we are having only two output, that is set or reset, but we have there are four possible input: 0, 1, 0, 1, 0, 0, 1, 1. So therefore, in order to save the time and also the resources, we are trying to modify the clock RS flip-flop and making the clock RS flip-flop having only single input. So therefore, we have only one input, that is D. So therefore, this circuit is known as D flip-flop. Now in RS flip-flop, when both input are same, the output either does not change or it is invalid. Now in case of when output is 0, 0, so it was no change. But when output is 1, 1, that was invalid. Now in many applications, these input conditions are not required. Now we know that that flip-flop has only two states, that is high or low. So therefore, our input like 0, 0 or 1, 1 are not required. So therefore, we can make just one input in order to save the resources. The input condition can be avoided by making them complement of each other, and this is modified RS flip-flop is known as D flip-flop. So therefore, we are removing two input and making input one. That type of flip-flop, which is modification of RS flip-flop, is known as D flip-flop. So you have only one input. So either your input will be 0 and 1. With the help of this one, this is inverter. So it will do the complement, and you will have the input similar to what we have in the RS flip-flop. When D goes directly to S input, its complement is directly to R through gate 5. So therefore, the only two input condition exist. So either your S will equal to 0, R equal to 1, or S equal to 1 or R equal to 0. So therefore, you have two conditions at the input side. Either your S should be 0 or R should be 1, or either S should be 1 or R should be 1, 0. So therefore, we have saved the resources by making one input. So this is the truth table, and you have only one input, D, 0 and 1. So in the previous case, we have two input, R and S. Now we have only one. And you have output here where when you give, so in this case, you don't have no change or that forbidden one. Instead, we have only two output. We had two input, that is 0 and 1. So therefore, you will have two output, that is reset and set. So this is the truth table of D flip-flop. Now, D flip-flop is the modification of RS flip-flop. Now we have again the modification of clock RS flip-flop, that is known as delay flip-flop. Now, before we go to delay flip-flop, let's look into JK flip-flop. A simple latch form is basic for the JK flip-flop. Latch are controlled by enable signal and they are level trigger, either positive level trigger or negative level trigger. The output is free to change according to S and R input value when active level is maintained at the input enable input. Flip-flop are pulse or clock trigger instead of level trigger. So if you have doubt about this sentence, flip-flop are pulse or clock trigger instead of level trigger. You can refer the books or you can search in the YouTube. So you will find many video where it explain about what is pulse trigger, clock trigger or level trigger. So here is the type of triggering. So this one is level trigger. When we say level trigger, your output will change when clock is at 1 or when clock is at 0. So this type of known as level trigger. So when we say pulse triggering, so it will be either positive edge triggering. So when the clock signal is at positive pulse, so the output will change. So when we say negative pulse triggering, so output will change when the pulse reach at a negative pulse. And edge triggering is this is the type of edge triggering. So this one is positive edge and this one is negative edge. So your output will change when your clock pulse reach out here. So that is positive edge, and the negative edge is when the output will get changed when your edge triggering is at this state. Now, so this is the truth table of JK flip-flop, and this is the logic diagram of JK flip-flop, and this is the graphical symbol. The difference between other flip-flop that previously what we have looked into and the JK flip-flop is in case of JK flip-flop, we have something called toggle. On top of having reset and set, we have action something called toggle. What do you mean by toggle? So toggle means when your output is switching towards one another. So if your output is 1, then it will switch to 0, 1, 0, 1. It will change the output 0, 1, 0, 1 like that. It will keep on changing. So such type of state is known as toggling. So therefore, this is the main difference between other flip-flop and JK flip-flop. Now, so you might be now getting headache because of so many type of flip-flop. But the most important thing that you need to remember is flip-flop are type of sequential logic circuit, which are nothing but output signal depend on the present input as well as previous input. The output signal also depend on the clock signal. Based on the clock signal, the flip-flop circuit will be start working. And the one thing that you need to remember is JK flip-flop is bistable state where it will store one bit. That means one bit, 0 and 1. So they are the storage device. So these are the main thing that you need to understand. And if you look into the slide that I'm going to upload, then you will understand the truth table, logic diagram, and everything. And in case if you have any doubt, you can drop me at any time. So this is the explanation of this truth table. So the only difference is toggling. Toggling, as I said, the output will switch from 1 to 0. It will keep on switching 1, 0, 1, 0, 1, 0. So such type of state is known as toggling. And we have a T flip-flop. T flip-flop is also known as toggle flip-flop. So that is the modification of JK flip-flop. Now, if you modify the JK flip-flop, then such type of flip-flop is known as T flip-flop, that is toggle flip-flop. Now, if you recall what we have studied about D flip-flop, D flip-flop is the modification of RS flip-flop. Now, similarly, we have JK flip-flop modification, where that is known as T flip-flop. Do you know the reason why we are modifying some of the flip-flop? So we are modifying JK flip-flop and making as a T flip-flop. The reason is simple, because we want to minimize the input. Now, in case of JK flip-flop, we have 4 input, 4 possible of input. If you go to the truth table out here, so you have 2 input, J and K, but the possible input you have is 4, 0, 0, 0, 1, 1, 0, 1, 1. But if you look out here, 0, 0, so we have only 2 input, that is 0 and 1. So we care only the output that we have, that is 0 and 1. So therefore, in order to minimize the input, or in order to minimize the resources, we are trying to modify the JK flip-flop, and that type of flip-flop is known as toggle flip-flop. So T flip-flop is obtained by JK flip-flop by connecting both input J and K together. When T equal to 0, both AND gate are disabled, and hence there is no change in the output. When T is equal to 1, that is J equal to 1, K equal to 1, the output toggles. So output will be toggle when both input are high. Now this is master slave. Master slave flip-flop. So in the master slave flip-flop, so you have a 2 flip-flop, where 1 flip-flop will act as a slave and 1 flip-flop will be act as a master. So one circuit will serve as a master and other as a slave. The overall circuit is referred as master slave flip-flop. A master slave flip-flop is shown below. So you just remember that we have type of flip-flop like master slave flip-flop, where we need two flip-flop in order to construct master slave flip-flop, where one type of flip-flop will act as a slave and one flip-flop will act as a master. So this type of logic diagram is master slave flip-flop. So this comes to the end of flip-flop. In the next session, we'll look into counter and register. So those are the example of sequential logic circuit.